but I'm going to this now. We move on to our final presentation, Pathways to Preservation Article Processing Workflows for the CLOCKSS archives, which are going to be presented by three of our colleagues from CLOCKSS. Again, I should have checked beforehand, shouldn't I? Which one of you wants to kick off? Okay, Megan is raising her hand. So Megan, do you want to take it away?
Yes. Do you see the slides?
Yep, I see your opening slide. That's fantastic. Thanks.
Okay, great. Let me. Okay, hi everyone. Today we're going to talk to you about the workflows that we use at the LOCKSS program to process journal articles into the CLOCKSS archive. Mary Ellen, Carmen, and I work on the Applied Preservation Services team at LOCKSS, which is based at Stanford University Libraries. Each of us will briefly introduce ourselves as we start our section. But I'm Megan Fraser. I'm the operations manager at LOCKSS, and I'm remotely based in Columbus, Ohio. And I saw some Midwest colleagues out there, so that's very exciting. I'm going to introduce some concepts that we're going to reference for the rest of the presentation, including more about how LOCKSS works and how CLOCKSS work. One housekeeping item about our slides, some of them have a lot of text that we wanted you all to have afterwards, but we're going to click through them kind of quickly during the presentation. So we're going to post a PDF link in the chat as the others have done for their presentation. Let's see if my next slide button will work. There we go. So first off, what is LOCKSS? You may have heard lots of copies keep stuff safe as a principle of digital preservation. But LOCKSS is also an open source software platform with a global community of users who rely on it to preserve digital materials. In addition to the software, we provide a range of operational and support services to preservation networks that are powered by LOCKSS. It is these services that we're going to focus on in this presentation. Specifically, we're going to zoom in on our work processing articles for CLOCKSS. CLOCKSS is a community-led international collaboration of academic publishers and research libraries that utilizes the LOCKSS software to ensure that scholarship is safely and securely preserved for future generations. I'd encourage you to view the CLOCKSS website to read more about the 5 essential facts on this slide, but I do want to highlight 3 of them. First, CLOCKSS is a dark archive designed for long-term preservation, and content is not available unless and until it needs to be restored due to catastrophic loss. Also, the archive contains content across many different disciplines and languages, which can create variation in our workflows. CLOCKSS preserves a wide variety of scholarly content, including books, proceedings, databases, though today we're going to focus on articles only. In terms of scale, in 2025, we processed 4 million articles into the CLOCKSS archive. The primary building block for our work, as I'm sure it is for many people's work on this call, is the archival unit, the AU. For us, this is comprised of a collection of files that can be crawled and has a defined start and end point. For us, this could be a journal volume that exists on a publisher's website, or it could be a set of zip files that have been delivered to us via FTP. The defined start and end point is really important for us. You're going to hear us mention overcrawling, which refers to when content shows up in an archival unit, but it doesn't belong there. This can cause space and metadata reporting problems, so it's really important for us to have well-defined AUs. I'm going to give you a very simple overview of a LOCKSS network, just so that you have some context to base the rest of this presentation in. So each of the servers in this image is running the LOCKSS daemon, which is another way to say the LOCKSS software. We call these nodes. Each node sends the LOCKSS crawler to crawl the content independently, and each node stores a copy of the AU, which is our little red folder icon there. Then, through the LOCKSS software, the nodes compare what they have and see if there's a problem with any copy of the archival unit. We can see here that one of our nodes has a corrupted copy, designated by the little exclamation point, that doesn't match the others. If there is a problem, as in this case, the node with the bad copy can repair it by crawling from the original source or from a peer in the network. And so on. This process continues to repeat as needed. CLOCKSS is slightly different. In the CLOCKSS setup, the content is first crawled into a staging network, which we call the ingest network. This works like a regular LOCKSS network, but it gives us the opportunity to work out all the kinks before content is preserved in the production network. Then the content is crawled from ingest to production. I will note that the diagram on the right does not have all of the lines. I assure you that all the nodes talk to each other. I just got tired of drawing lines. So just a footnote. So to bring this back to our pathways for preservation, let's talk about the 2 primary pathways that content travels into CLOCKSS, which is web harvest and file transfer. With Web Harvest, we are crawling the content from a web page, similar to the web archiving we heard about earlier. The crawler is given access via IP-based subscription and the presence of the CLOCKSS permission statement on the website. We also need a start page to limit the AU to only a portion of the site. For Web Harvest, the start and end points of the AU are driven by bibliographic information, so the volume, the year, etc. For file transfer, content is delivered from CLOCKSS partners, mostly via FTP, and the crawler crawls them from a staging site, which Carmen is going to talk about. Here, the AU is based on the delivery time and size, not the bibliographic metadata. But the bibliographic metadata is important because we will need it for reporting and later discovery. While there are fewer AUs in the archive that come via file transfer, they are much bigger. More than 80% of CLOCKSS articles are delivered in this way. We also shout out Works and Project Jasper on this page. Those are special types of file transfer content that we ingest into the CLOCKSS archive. And with that, I'm going to turn it over to Carmen to talk about how we create the code to ingest the content.
Thanks, Megan. My name's Carmen, and I'm one of two plugin developers on the LOCKSS team. And today I'll be going over what a plugin is and how I evaluate publishers' websites in order to create plugins. So next slide. So what is a plugin? A LOCKSS plugin is a bundle of rules and code adapting the general LOCKSS software to the particulars of a given preservation target, such as a publishing platform. So in this example, I have a screenshot of all the files needed for the OJS plugin or Open Journal Systems. Next slide, please. And this is a screenshot of what one of those XML configuration files looks like. This is just to give you an idea of how human readable it is, even if you don't have a developing background. These files are kind of like the instructions, and it's easy for anyone to kind of look through and kind of get a sense of like what is a part of a plugin. Next slide, please. So as Megan mentioned earlier, we have two main ways of collecting content. The first is file transfer or FTP. Generally, that is a lot easier, much easier way to collect content through a plugin. And that's because the publisher sends us all the files in these nice little zip files. And usually these zip files contain a PDF of the article, as well as a corresponding XML that contains all of the metadata. And this right here is a screenshot of what one of those FTP buckets looks like. A Web Harvest plugin, however, is generally much more difficult to write, and that's because the plugin will be going out into the wild, wild west of the internet, and I have to set very clear rules so to make sure that the plugin doesn't go off too crazy and starts crawling like the whole internet. We definitely don't want that. So next slide, please. So just to hopefully all of you are awake because I have a small ask for you. So just to give you an idea of what I do in my day-to-day job, I look at a publisher's website. So you can go to the next slide. And I want you to look at this example and look through and type in the chat what you think is something that's important to collect, like what is considered scholarly content, and what is something that maybe we should avoid collecting. And I'm going to give about 30 seconds for the audience to give some answers. I hope people are awake. Can people collect everything? That's my... Okay. Yeah. Okay. Great job. Okay. There's some good answers. So Rich, you are correct. So Megan, you can go to the next slide. I would skip these recommended articles. And the reason being is that those aren't necessarily part of the current archival unit. So you can see that there are articles from 2015, 2016, 2010. If we collected those, that would result in an overcrawl, where we're collecting articles that are not part of the current specific AU. We would grab the supplementary material that is considered part of the scholarly content. And if you'll notice this advertisement, generally advertisements have links where you can click on them. That's something else that I would avoid collecting. Partly because that advertisements change. As you refresh the page and as then the website collects information about you, usually adapts the advertising to the user. So that's something that we don't want to collect. Okay, next slide. So what are some of the things I look at when I'm evaluating? One of the other things I look at is how dynamic a website is. So in layman terms, that just means like, is this content that is generated on the fly, or is this something where all the HTML files come as is? If these are pre-built HTML files, that's generally a lot easier for the plugin to collect. It can find everything that it needs. Whereas if it's dynamic, that is a bit more difficult for the plugin to find all of the files necessary to build a copy of the website. Next slide. Another thing I look at is metadata. More modern websites generally have these really nice meta tags. That is a lot easier for a plugin to find. They're nicely labeled. Whereas older websites don't have these meta tags, and it can be more difficult for me to find for a plugin for me to write a plugin that can find all of the necessary metadata. Another way I get metadata, and this is generally more in the FTP or the file transfer, the one that's kind of like nicely contained files. Um, Usually that metadata comes in a XML file, and it's usually in a schema that's known to us. The next slide. So another thing to look at is the URL structure. It's very helpful if the URL structure is predictable. So if this is like a good URL, the first example, where it has a journal ID, a volume number, and an issue number, and even has TOC in the URL, which stands for table of contents. So that's something that I can easily write crawl rules for. Whereas if my cat Paul started, thinking of URLs, it would be absolute chaos, and that's generally a lot harder for me to write rules for. Next slide. So with all that said, once I evaluate and write the plugin, this is kind of like a very brief overview of like all the things that a plugin should accomplish. Does it collect all of the scholarly content specific to the archival unit? Does like the right amount? Doesn't overcrawl or undercrawl? Does it list the accurate number of articles? Does it collect as much metadata as possible? And does it provide a representative replay of the website? Next slide. So with all of that said, in actuality, the majority of my work is maintenance more than writing new plugins because websites change over time. And at this point, I'll turn over to Mary Ellen, who helps me find when those websites change and helps notify me when tests are failing, when I need to update plugins. So with that, I'll hand it over to Mary Ellen.
To remember to unmute myself. Thank you, Carmen. My name is Mary Ellen Petrich, and I'm a digital preservation analyst with the CLOCKSS program based in California. And I'm going to talk about testing our content against the software. Here is a visual representation of the CLOCKSS processing flow, which shows the many detailed steps we follow, highlighting in the center places where errors are discovered and resolved. Once content is tested successfully, it's released to our ingest network, reviewed for completeness on the ingest network, and then released to the final preservation network. Here is a different representation of our workflow showing the status words we use to define where we are in the preservation pipeline. For example, manifest indicates that the item is ready for testing, and testing indicates that the item is under test. Here is a very cute turtle and a rough outline of the steps we take before releasing content to the staging network. Discover, document, test, and debugging where necessary. We release content to the CLOCKSS network year-round, about 1,000 archival units per month. We have some automated ways of discovering new content, but mostly we add new content on demand. The CLOCKSS organization provides lists of titles with relevant parameters. We have automated methods for determining if the content is configured correctly for testing. Like Carmen, I have a lot of maintenance on my side of the house, and we have a variety of scripts that discover quality control issues such as journals joining a publisher, journals leaving a publisher, journals changing their website, also typos, incorrect ISSNs, and so forth. Once content is discovered, we document it. Our title database is a supercharged catalog which provides basic metadata for what we were preserving, but also specifies parameters for each archival unit. The parameters are used to define the AUID, which is a string of characters that passes parameters to the designated publisher plugin, and also serves as a unique key to the archival unit contents on the server. As I mentioned before, the TDB file also has an AU status for each AU that both defines what stage of preservation the AU is in and controls how the general lock software acts on the content. This is an example of a file in the title database. You can see metadata like the publisher name. There are parameters like the base URL, the journal ID, and the volume. Also, each volume of the journal has a status to indicate what stage the preservation process is at. Each volume is tested against 2 servers. Testing is separated by 12 hours so that we can identify changes to the site which happen over time. I've listed some of the errors we discover in testing very quickly, but I'm going to come back to these. After finding content and documenting it, we want to test it. The first step is generating the AUID. This is an Eclipse ID interface, which allows us to run a script to generate the AUID. AU Test is a custom internally developed tool that we use for automated testing. This screenshot shows how we add AUIDs to the interface. AU Test is then able to add the AU to the general lock software on a selected server, start a web crawl, record the result, wait 12 hours, start another web crawl in another server, and finalize the test results. After at least 12 hours, but sometimes many days, this is what the output for testing looks like. All the archival units have passed testing perfectly except for the top one, which has a 99% agreement between the 2 servers it was tested on. This is what a successful result looks like. You can see that we record lots of information about timing, some metadata and URL and article counts. And this is what an unsuccessful result looks like. These archival units from the Public Library of Science are really big. They have hundreds and thousands of articles. Because the LOCKSS crawler is a friendly bot, we crawl all sites at the publisher mandated speed. So for a large set of content like this, it takes 4 or 5 days to collect all the articles and web pages in the entire archival unit. I'm going to talk a little bit about sorts of errors we run into. They fall into 4 categories, and here they are ordered approximately by when they occur in the crawl. The first type of error is when we can't fetch the start page. I've listed out some reasons why that might happen and some solutions. The problem might be on our side that we're trying to preserve a volume that doesn't exist, or there's a typo in the TDB file. The problem might be on the publisher side, and the site may be missing permission statement that tells the crawler to collect content, or the start page might be missing entirely. Journals also move from one publisher to another. Another type of error that we see is that we don't have permission to crawl the content. This is often, but not always, a subscription problem. It's sometimes hard to identify these kinds of problems because the symptoms can be so varied. A third type of error happens when, as the LOCKSS crawler moves through the site, an HTML error occurs. The crawler usually lists simple 404 errors as warnings, but there are plenty of others which stop the crawler in its tracks, such as 401, 403, 500, and 520 errors. Some more unusual errors occur when absolute URLs are formatted like relative URLs in error, and when URLs take the crawler back to the same page over and over again, thereby building up a recursive URL. Finally, there are many reasons why, when comparing the content collected on 2 servers, it might look different. All those differences have to be encoded in the plugin. Some differences are transient, And over time, they either disappear or are collected across all servers. Other types of differences are purposeful and vary over time and location of the viewer. These include ads or pointers to current popular articles. Each member of our team has specialized expertise. When we discover a problem, we distribute resolution to the right person on our team to solve the problem. And now I will hand the mic back to Megan.
So after we've done all of the plugin development and testing and content ingestion, we have to do statistics. We have to do a lot of reporting. So I'm going to talk very briefly. I know we're almost out of time about statistics and reporting. So each node of the network has a metadata database, and those are copied each week to create a larger database that we query for reports. Combined with our title database files that Mary Ellen discussed and reports from our Jira instance, we provide a selection of weekly, biweekly, and monthly reports to CLOCKSS. For the reasons we've mentioned, it's important to be able to count one article one time across ingest and production nodes. So in our databases, we generate a key for each article using the metadata. In this situation, we would much prefer to use an identifier like the DOI, which makes this deduping less error prone. For example, you could imagine that a second delivery of the bottom article might have the title to have a hyphen in it. And then that would create different keys and it would count the article twice. So we use an identifier wherever we can. In conclusion, we did include a list of the tools that we use in case folks have specific questions about those and would like to reach out to us. I noticed Amanda's team also uses Jira, so we're heavily into Jira. And please feel free to reach out to us with any questions. All of this contact information is in the PDF that we shared. And thank you very much for attending today. We'll happily take any questions that folks have.
Thank you very much. Carly beat me to it and kicked off the floors. Thank you again. Do we have any questions then for Mary Ellen or any of the other speakers? Megan? Carmen? Sorry, I'm not sure. Susan is saying it's nice to see all of this detail, and I absolutely agree. It's good to see what's under the hood and what goes on behind the scenes, all the hard work that goes into doing this. So I have a quick question for Carmen then. So you said about the plugins that 70% of the work is maintenance. And again, sorry if you said this. So do you have to write a new plugin for each kind of journal? And if so, is like 99% of it the same, but then you have to tweak stuff to count the kind of curious features of that particular journal, or are you kind of having to write huge swathes of code from scratch and then maintain it going forward?
So we have quite a few plugins. Usually they're adapted to publishers as opposed to journals.
Okay.
Single publisher will have a bunch of different journals. A lot of it is repeatable, but I always have to kind of like tweak them a little bit to specify exactly like that publisher's website. But whenever I have to like do the maintenance part, I don't have to like start from scratch. I just go back to the plugin that already exists and then just kind of like move things around. Does that make sense?
Yeah. And when publishers, as I gather, have a habit of acquiring one another, do they mess up your lives? Do they sort of insist on reformatting all these articles into their whatever their new house structure is, and you have to?
Unfortunately,
yes.
Our favorite changes. Oh, go ahead, Carmen.
Yeah, and sometimes it's something that like we catch only through testing. So it can be like, oh, they completely restructured their site. So what were you going to say, Megan?
No, I was going to say one of our favorite changes is when a publisher adds next previous buttons, and we'll have an AU that was working fine and collected what it was supposed to collect, and all of a sudden it's 20 times bigger than it was, and because of these lovely user-friendly previous next buttons.
And maybe that picks up the question that Christopher's just put in the chat about. He said, in testing, which error or what error is the most frequent? Is there one that stands out?
I think that's sort of an interesting question. I mean, I would say that the problems that happen at the beginning of the crawl are the most frequent, but part of the thing is those are the ones you run into first, right? So if there's a problem at the beginning of the crawl, you're going to find that first, and then you're going to try it again and run into more problems later on. Also, if you asked Carmen versus me, which problems are more common, probably be different ideas, because there are some kinds of problems that I can fix without her help. And there's some kinds, and there's some kinds of problems I'm never going to be able to do anything about, and I need her to fix. So that's an interesting question.
I would also say that currently we're running into a lot of problems with bot blocking because, rightly so, all over the web, folks are putting Cloudflare in front of their websites, and even though we're a good little bot, they don't know that. So we get stuck on the human, are you a human challenge, and so we're currently working on. And so I would say since I've been here, I've seen. Sometimes we'll get like ebb and flows of particular errors where like this error starts to happen because this thing is trendy, and then it stops, and then something else starts to happen because something becomes a different trend.
Yeah, and this isn't even the first period of time when this kind of thing has happened. I mean, it's very intensive right now. But there was a period of time when crawl blockers were just becoming popular, and it was a problem for us, like 10 years ago or 12 years ago or something like that. Yeah. Now this is another new thing. That has been the biggest, it's probably the thing that we spend the most time on now, I would say.
Okay. All right. Well, I wish you well. I can, and thank you very much for that. I'm just slightly conscious that I've blabbed and we're getting near the end of time, and I did want to wrap things up.